right, so let's get started. So as already mentioned, like in the next 30 minutes, I will give you like a deep dive into advanced TypeScript, and maybe you can learn some stuff you maybe not have used before. Yeah, sure. I already got an introduction, but I will do one short myself. My name is Christian. I've been working as a full stack engineer like for the last 14 years now. I also do like trainings and code reviews on the side. I really enjoy speaking at conferences like your jsday, and also I recently started doing some content on YouTube. So if you're like interested in stuff what you see today, just visit my website type.rocks. There you can click on my YouTube, and there is more stuff what you see today. Just much more on my YouTube channel. So if you have questions, I was told that you can scan this QR code and then we can answer the questions later. I think it will be a little bit close what the time is because the keynote will be after that, but you can just ask me the question like on LinkedIn, send me a message and we can talk there. So let's get started right away. So I will talk about 6 topics today. So the first thing we'll talk about is mapped types. So let's say we have a type here, and let's say we have 2 properties in there, an add property and a remove property. Now let's say we have a user actions object here, and this is of type onEvents. Now what we want to do is we want this onEvents type to have one onEvents function for each of the events here. So we have an onAdd, for example, and we have an onRemove here. So what is now the issue with this? Well, of course, we have to create this onEvents type. So let's create this here. And what we now could do is we could create them manually. So we could just say we have 2 functions in here, and we can create them like this. Now, what is the problem we have here? The issue is that when we change the events, for example, when we say we have move in here, then everything still works as before, so we don't get a compile time error. But what you want to get is you want to have a compile time error that here one function is missing, so that this onMove function is missing. Now, this is because, of course, these 2 types are not in any way or shape or form connected with each other. And this is why we can use mapped types. So the first thing we do is we first create a new type. Let's call this type events keys. And we say this is key of events. Now what this contains is, we can see here, this is just add, remove, or move as a union. So you're now only allowed to use these 3 strings if you use this events keys type. By the way, all this code is also on my GitHub, so you can find all there. So if you don't want to, you don't have to like pictures because then you type it by hand, but you can just find it there. So what we then can do is, let's just remove these fixed types here, and instead, let's use a mapped type. So we say we have a key, which is in events keys here. Now, what we do with this approach is, we just loop over all the keys of our event keys union. Now, as a value, we just say this is just a normal function. Now we can see here we have 2 issues here. The first one is we have to rename onAdd to add and onRemove to remove. Now we can see here everything compiles, but this object does no longer compile because what we need to do is we need to add this move property in there. So what we now have achieved is like that we have these events and then we have this onEvents type which depends on it. But what now is the issue is we have lost this on prefix, right, and this uppercase first letter. But we can fix this because when you use like JavaScript or TypeScript, you can like map over a list. And we can do exactly the same here with our key. We can say as, and we can use backticks, and these are like template literals. They work like in JavaScript or in normal TypeScript code. So in there we say you want to have a prefix of on, and then we just pass our key with our curly braces and the $sign. And now the TypeScript compiler understands that we need to prefix everything with an on prefix, otherwise it will not compile. Now the last thing we need to do is we need to capitalize the first letter of our events keys here. And we can use an intrinsic function for this. So we call capitalize, we wrap our key in it, and we can see now we have to capitalize our first letter here, and now it compiles again. Now capitalize itself is a so-called intrinsic function. So this is done inside of the TypeScript compiler, and we cannot see how the type itself works because it would be too complicated to show in pure types. But because of that, when we now change the remove to delete here, we can see that we now get an error down here because we now need to name it on delete. So we also have auto-completion, everything still works. But with this approach, we now have like a base type, the events, and we use it to create a new type, so we only need to change like the type at one place and everything else gets derived from it. Now, the next thing we want to talk about is about these template literals here, because we can do much more with them. So let's say we want to have like a margin padding type, like we want to have margin left, right, top, bottom, and the same for padding. We could create them manually and create like a union where we create each string ourselves. But this is really error prone because when you misspell something, then you have not the correct type. So we can let TypeScript do the heavy lifting. So we can say we have our gap here, and this is either margin or padding. And we can say we have here the position, and this is either left or right or top or bottom. And now we can use template literals to combine them with each other. So we say we have our margin padding type, and these now are created by the template literals. So we say as a first one we have gap followed by our position. And what this does is it creates a permutation of all the possible combinations of gap and position. So because of that, there is a high chance that you don't do like any errors in your typing, because you only have to do it once for gap and once for position. And of course, this also works for other stuff, like you can do it with any kind of strings. You could also say it has to start with a gap and, for example, then has to end with a number. So you can combine all your own types with it. Now that we have seen how these template literals work, let me now show you a type. Maybe some of you have already seen, but maybe lesser ones of you have already used it. So let's talk a little bit about the never type. Now, let's first see how the never type works. So let's say we have an hello here, and this is a string, and we say hi jsday. Now, of course, this is a string, right? But what happens when I change this to never? Let's see what the error is we get here. We can see here string is not assignable to type never. Of course, because like never is another type, it's not the same as string. So how can we normally fix this? We just say as any. But we can see here, in this case, this does not work, because not even any can be assigned to never. Because the special thing from the never type is that only things which are never can be assigned to never. And this will help us in cases, for example, like exhaustive switches. So let me show you what I mean with this. Let's say we have a type here, locations, and this is either, let's say, Zurich, or let's say this is London. Now, let's say we have a function here, get country for locations. We pass in our location, and we return a string. Now, for each of the location we pass in, we want to return the corresponding country. Now, how can we do this? Of course, we can use if-else, but in this case, I will just use a switch statement, and I say location here. And let's use the case for London, and we can see here, we still get an error for our return type. Why is this? Of course, because the case for Zurich is not covered. So TypeScript understands that when we pass Zurich to this function, it will return undefined. So this is why we get an error here. So let's fix this. We say case Zurich, and we say here Switzerland, and now everything is fine, right? But what happens, let's say, if you are a library author and somebody which uses only JavaScript and not TypeScript uses this function? Then it will look like this. You have, like, for example, one calls it with Paris or anything else, and it gets always called like with as any, because if you don't have like JS enabled, then you don't have these types. Now, the issue with this, of course, is that now you only get back undefined. This is why it's mostly not enough to only have like compile time checks from TypeScript, but only have some runtime checks in place. So let's say we add this here, we add a default case, and we say throw new error, and we tell in here, well, the location is not known. Now we have the runtime safety, right? But what happens if we now go back and say, okay, we also want to support Paris here. So we go in there and we say we add a union with the string Paris. Now, you can see here what we have lost. We have lost the compile time safety from TypeScript, because now TypeScript sees, well, okay, there is no branch covering Paris here, but maybe this is what the developer wants. So I will not show the developer a compile time error and tell, hey, you have forgotten to add this case switch. And this means that when we call this, we get an exception. And now, because of that, we have lost the compile time safety in favor of the runtime safety. But we can use the never type to achieve both. Because what we can do is, in the default case, we just create a new variable here, and let's call this exhaustive. You can call it whatever you want. But we say here the type has to be never. And now what we do is, we can see that when we try to assign location to the never type, we get an error. And we can see here, string is not assignable to type never. Now let's backtrack what happens here. TypeScript figures out we have these two branches covered, so London and Zurich, but Paris not. So TypeScript understands the only two possible types which can be here at this location is never and Paris. And when we hover over this, we can see here Paris is the type which TypeScript resolved. And because you cannot assign something which is not never itself to never, this means that we get an error here, an exception here. So, but what happens when we add a case switch for Paris here and we return France? We can see the error goes away because TypeScript understands that the only way where you can reach this location is never, basically, and when something happens which shouldn't happen in TypeScript. Now, you're maybe telling me, okay, but now we have this variable here which is unused, right? So we can remove this and we can use the satisfies keyword instead. So we can say location satisfies never, and this means that in this branch of our code, we check if the location, the type of this location, satisfies the type we've defined here. So, for example, when I now remove another branch, I remove Zurich here, we again get an error because, as you can see here, we now get again the error string does not satisfy the expected type. So, of course, this also works with if-else cases. So you can use also like exhaustive if-else cases to be sure that you have covered all these branches and still have the runtime safety in place. So by using this approach, you don't have to like sacrifice the runtime safety for the compile time safety or vice versa. You can have it both by using the satisfies never keyword inside of your default branch. So we have now talked a little bit about how never type works. Let me now show you how we can use recursion to create your own types. So let's switch over here. And so let's say we have a type here. Let's call this type RGB tuple. Now this is just a tuple with 3 elements. And for the one of you who have not worked with tuples, tuples are just like fixed length arrays. So you have like an RGB tuple here, and you say 1, 2, 3, this is allowed. But as soon as I remove one element, then we get an error because we need to have an array with the exact length we specified here. Now, this is really easy to understand what it does, but let's say we want to allow like 3 or 4 elements. So we would have to copy this, and we would have then to create a union which allows 3 elements or 4 elements. And if you now want to also change it to allow like strings or numbers, you always have to change them and you have to count how many elements are in there. Now, let's say you want to have something like with 10 elements or 20 elements. Then it's really error prone because maybe you did the wrong counting. So wouldn't it be nice if you had like a function which has it's like called tuple, and you say how many elements you want in there and what types you want. Well, sadly, as you can see here, there is not such a type, but we can create one ourselves. Now, before we start to create one, let's think how we would create such a tuple in JavaScript or TypeScript. Let's say we have a function and we call this tuple, and the first element here is the length we want to have. The second one is the type. Let's just make this any, and we have an accumulator because we will do this recursively. We have to recursively call our function and just build up our tuple array. Now we say here this is an any array in this case, and we initialize it with an empty array. Now what we would do is we would say, well, if the length is the length of our accumulated array, then we just return our accumulated array. Otherwise, we would just call tuple again with our length, our type, and we would create like a new array, spread our existing one into it, and add a new type to it. And we can do exactly the same thing in TypeScript types. Now, why do I show you this with recursion? Because in TypeScript types, you can't use like a while loop or for loop. So you always have to use recursion, like you would like in Haskell, for example, where you have just like your normal recursive calls. You don't have like normal for loops. So let's see how we can do this with types. So we say we have a new type, and we need to make this a generic one, which takes type arguments. The first one will be the length type, and the second one will be our type here. Now, the third one is our accumulator, where we say this has to be of the type we pass in here. And we also initialize it with an empty one, so that we don't have to initialize it every time we use our tuple type with an empty array. And now we can start to implement this. So the first thing we do is we say if the length extends the length of our accumulated type, then we return our accumulated array. Otherwise, we do something else. But let's first look into why does this work? Because let's say we pass in here a 3. And why can we access the length of a type? Because TypeScript itself, in its compiler, also needs to know how many elements are in an array, because otherwise, in a type array, because otherwise this one here would not work. You could not tell TypeScript you have a fixed length array of 3 if TypeScript would not have known how many elements are in there. They would not be able to check if we have passed too many or less elements. So because of that, we can check if the length is the length of our array. If so, we return it. Otherwise, we just do exactly the same as in our JavaScript or TypeScript. We just call tuple again. We have our length here. We have our type. And now we just create a new type array, spread our existing elements into it, and add a new one to it. And we're already done. So let's remove this here. And let's see what's happening here. We can see here, this has now created for us a tuple with 3 elements. Now, the cool thing about this is that we can say, for example, I want to have 3 or 4 elements. And this will now create a tuple which allows 3 or 4 elements in it. We can also say I want to have like 3 elements which are numbers or strings. We can go as far as, for example, we want to have a tuple with 999 entries. But as soon as we change this to 1,000, we can see TypeScript does not allow this because it has like a hard recursive stop at 999 recursions. But we can see here for normal stuff, like for example for our tuple, we can see it's really easy in like 4 lines of code to create like a generic or like a utility type which can help you to write much less code, because this way you don't have to write your own tuple type for every possible combination. Now let's go to the last topic here, and many people came up to me and asked, well, when should you use these kind of types? Well, because maybe the people won't understand them. And I always say, of course, only use them if you really have to, but always think of these types as like a library. For example, when you use in JavaScript or TypeScript, when you call sort on it, you also don't know how it's sorted. You only know what is the outcome. And as long as you can understand what the outcome of such a type is, I think you can use it without any issue. But even when you don't want to use this kind of stuff, let me show you something which I would really suggest everyone to use, especially when you work with different domain objects, because I think branded types are really important to keep your code easily maintainable. So, but let's get started first easy. Let's say we have an email, right? And this is of type string, and we say here we have me@type.rocks. And let's say we want to send an email. I have a send email function, and we have this input here. And in here, we just send the email. Now, let's say we want to make sure that this send email here only takes a valid email string. Because currently what we can do is we can just call send email with our email type, with our email object, but also we can call send email with totally not an email. And what we now could do is, of course, we could, inside of send email, do an if check. So we could check in here, is this a valid email? If not, we'll just throw an error or do something. But we don't really want this, because the send email should be only responsible for sending an email. And it should already know that the data I get is a valid email. So let's say we create a function here, and let's call this isValidEmail. and we have an input here, and we say return a Boolean, and then we keep it easy, we keep it simple in this case. We just say if the input includes an @ sign, this is good enough for us. And now we can just wrap our send email here. So we say is valid email, and we pass our email. Now we can see here, of course, this now works, and we have now covered this, but this send email here is still valid because this is just taking a normal string, and we have no way of filtering this. So there are different ways people try to solve this. One possible thing is that we say we have a type here, let's call this email, and we create a wrapper. We have like an email string wrapper here, and everywhere we want to use our email, we pass this wrapper object. So for example, we pass in here our email. But what is the issue with this? The issue is that in here now, if you want to use your email as a normal string, you always have to unwrap it. Let's say we have a function, and this function is just like a log function, which just takes a string. And this does like a console log, for example, here, logged. And then we have our string here. Now, we cannot just call it from inside our send email function because this is now wrapped. So everywhere we want to really use it as a string, we have to call the property email string. So this is why I don't really like this approach. And what I really would like instead is that we can create our own email string. So let's remove this here again and say email is an alias for a string. Now, when we could tell TypeScript somehow, listen, everywhere I pass this email, I want it to be a string, but a special kind of string, then we could solve this issue with that this here still works with totally non-email. But let's see how we can do this. The first thing what we do is we create a type guard. What is a type guard? We have here this isValidEmail function, and currently this just returns a Boolean, so true or false. But we can tell TypeScript input is email. Now what this does is it tells TypeScript, hey, we pass in here this string. But if this function here returns true, this means that this string here is a string, but it's a more narrow type. So it's a more specific kind of string. Currently, we can see nothing really changes because when I remove this, we can see here that send email still works. Because what we were basically telling TypeScript here is, hey, we pass in here an input, which is a string, and if this returns true, then the string is a string. Because we have, this is just like an alias. TypeScript will not understand that this is like something else than just a normal string. But here comes branded types into play. Because what we can do here is, we tell TypeScript, this email type here is not just a string, but it's a string and it contains an additional property. And I like to call this property brand here, but you can call this anything you like. It doesn't really matter. But I like to call this brand and then assign it the value email. Now also, this is also not needed. You can pass anything in here you want, but this is just so that we can easily see to what it belongs. And now we can see something changed because line 18 does no longer compile. Because when we hover over this, we can see string is not assignable to type brand email. Now what happened here? We tried to pass a string to this send email function. But the send email function takes something, a type, which is a string, but also has this additional property brand. But because a string does not have this property, this will not be allowed. But we can see here 14 to 16 still compiles because of our type guard. Because what the type guard tells TypeScript here is, hey, we have a string here, but when this returns true, you can trust us that this string you have also contains this additional property. Now, don't get this wrong. This does not really, when you compile it to JavaScript, this does not really contain this brand property. This is only for the TypeScript compiler or for TypeScript to understand that this is some special kind of string. When you would log here, for example, when you would have a console log of input.brand, this will be undefined all the time. Now, we can also remove this from our autocompletion, that this is not even available, by using a so-called unique symbol. So we create a new variable here, and we call it brand, and we say this is a unique symbol. And this will help to hide it from TypeScript from our code, so that we cannot see it when we try an autocomplete. So we leave it like this. And we now can see when we use input, we can see the brand is no longer available. Now, what you also can do is, we can see here we have this isValidEmail in here. Now, what we want to do maybe is we don't want to wrap everything in an isValidEmail, but what we want is that we have an assertion. This means in 99% of all cases, this email here will always be a valid email. And otherwise, it will just throw an error. So what you can do is, we can copy this, and we can just say here asserts valid email. And now instead of just saying this is a type guard, this is a type assertion, and we could just add asserts in front of it. And because of that, we can see we are no longer allowed to return something, but we need to handle a case where input is not an email and throw an error. So what we say here is we say if the input does not include an @ sign. In this case, we throw a new error, and we keep it easy and say input is not an email. And because of that, what we now can do is we can change this from isValidEmail to asserts valid email, and we don't have to put this in an if else, because what now happens is that TypeScript understands that as soon as we call this asserts valid email function, when we reach the next line, so if we reach line 23 in this case, TypeScript understands that this email has to be of this type email here. Otherwise, TypeScript thinks we would have thrown an error. So this means when I move this up here, we can see I get an error again, because up here, the type of email is just a string. If I move this down here, we can see that the type of email is now email. So for example, if you have like a GET request, you make like a REST call to an endpoint, and you get your results, and you want then to work with your narrowed strings or your narrowed primitives, you can use such an assertion, and everything after this check will then be sure that this is really a valid email, and you can work with this more narrow type of string. But let's also think what you could do also, not just with email. You can use this, of course, for any kind of string. Like, for example, me personally, I use this for UUIDs or like phone numbers, or if you have like a special kind of string which has to have a certain shape, you can just brand it with your own type, and then everywhere you use this in your code, you know that your string is really of this type you want it to be, in this shape. And also, I have to mention this again, this is just still a normal string. You can use it everywhere you would pass a string. You can pass your branded string. And the same thing you can also do, for example, for numbers. You could say you want to have an integer, and you say this is a number, and you say integer, and then you have like a check if a number contains some floating points or if it's just a normal integer. And everywhere you then use this integer, you can be sure, or this integer type, you can be sure that this number you're passing around is really a normal integer and does not have like any decimals. And I think this is really helpful, because when we often have like domain-specific language which is, for example, we have IDs, isn't like we want to be sure that everywhere we pass this, we can be sure that this is not just any kind of string, but this way we can work with this stuff much easier. Now, what I want to show you before we go to the questions is what you also can do. So like one of the most often asked things in like when you do a coding interview or on lead code is like reversing a linked list, right? And what you also can do is you can also just create, you can also just reverse a linked list in, or for example, invert a binary tree in TypeScript types. And if you're interested in stuff like this, you can just visit, we can just go to my website and visit my GitHub. There I show you like stuff like how to reverse a linked list, invert a binary tree, all just in TypeScript types. But also what you can do is, for example, you can create a calculator validator only in types, which only compiles when the string you pass in is a valid arithmetic expression. So for example, when the brackets here are in the wrong order, or when the whole string cannot be evaluated, then it will throw an error at compile time. Now if you want, this is also my GitHub, and it's done like in 40-50 lines of TypeScript types code. So this will also show all the stuff I've shown you today, but also more because the time is a little bit limited. As for example, if you're interested in like stuff like infer, please pay the visit. I think you will find some interesting stuff there.